What up, 8th grade? We're here in the last section of chapter 2. We're going to be talking about function notation. I hope you're ready because this is a big part of Algebra 1 and Algebra 2 and geometry and actually every single math class you're going to take until you quit taking math classes. Okay? This is not going to be anything new. There's no new concepts here. We're just changing the way that we write equations and functions. Okay? So far in this chapter, we've worked with functions in tables, charts, mappings, and graphs. Now we're going to be talking about them as equations. Okay? And all function notation is a specific form that allows us to better see what numbers we're plugging in. Okay? Typically, we've seen the equation as y equals 3x minus 8. Now we have it looking like this. Okay? That f parentheses x, the way that we read that is f of x. That means we have a function that involves x. Okay? 3x minus 8. If I did f of z, it would be a function involving z, something like negative 4z plus 1. Okay? So whatever is inside those parentheses is what gets used in the function. Okay? That's all function notation is. It's replacing y with f of x or f of z or f of y or whatever your variable is. So let's take a look at some examples of how this works. Okay? Find each value for the function. So my function is f of x equals 2x plus 5. What I'm going to do is I'm going to take this negative 2 and I'm going to replace it wherever there's an x. Okay? So that means if I'm finding f of negative 2, wrong color, f of negative 2 equals 2 times, remember I'm going to replace it, so it's not an x anymore, plus 5. Okay? Now I'm just simplifying. I don't have to do anything to the left side. There's nothing I have to do over here. That's just f of negative 2. So I'm working on the right side with 2 times negative 2 to get negative 4 plus 5 is 1. So that's my final answer. F of negative 2 is 1. Okay. If we were to put this into a typical xy chart like we had seen, it would be x f of x instead of y. My x value was negative 2. My f of x value was 1. That's all it is replacing y with the term or phrase or function notation is f of x. Okay? Let's try another example. Using the same equation, same function, we still have f of x equals 2x plus 5. Now we're going to do f of 4. So I'll have f of 4 is equal to 2 times, I'm replacing my x with the number 4. Pretty simple. And I'm just simplifying again. There's nothing on the left side. It's just f of 4. So on the right side, I do 2 times 4 is 8 plus 5 gives me 13. Okay? So the function involving 4 is equal to 13. F of 4 is 13. All right? We can make this a little bit more complicated. It'll get a lot more complicated when you get to Algebra 2. But this is the farthest we're going to go. We'll do a little bit more than this as far as difficulty goes. But now we're going to find f of x plus 3. Okay? Remember, back to our original function, same thing. F of x is equal to 2x plus 5. All you're doing is replacing x with this time replacing it with x plus 3. Okay? So I have f of x plus 3 equals 2. Now here's where I replace it. Where I had 2x, now I'm going to have 2 times x plus 3 plus 5. And I'm still just simplifying as far as I can. I have the distributive property here, so that gives me 2x plus 6 plus 5. Then I have 2x plus 11. So that's my final answer. Okay? We didn't plug any specific number in for x, but we plugged in the phrase x plus 3. And so f of x plus 3 is equal to 2x plus 11. Okay? That's really all function notation is. Okay, we have some more examples on the back to continue practicing. So let's take a look at those real quick. Okay? I have a different function now. Typically, you're always going to see functions using either the letter f or the letter g. Okay? So this time we're going to do it with g of x. And in particular, for example 2a, I'm going to look at g of negative 4. So I'm going to take g of negative 4. I'm going to plug it in every single instance that I see an x. So I'll have negative 4 squared plus 3 times negative 4 minus 4. Notice I took the negative 4 and I plugged it into that x and to that x, where my x's were. Okay? Now it comes down to simplifying. This is why we spend so much time practicing our order of operations. Negative 4 squared is 16. Positive 3 times negative 4 gives me a minus 12. I still have minus 4. 16 minus 12 is 4, and 4 minus 4 is 0. So for this function, g of negative 4 is equal to 0. Okay? Example B, we're still going to use g of x equals x squared plus 3x minus 4. But this time I want to do 2g of x, 2 times g of x. So am I changing anything that's on the inside? Am I replacing x with anything new? No, it's still staying as an x. What I'm doing is I'm taking the number 2 and multiplying it by g. Okay? So if I want 2g of x, what I'm going to do is I'm going to take 2 and I'm going to multiply it by g of x, which is x squared plus 3x minus 4. Okay? So to simplify this, we see a number outside parentheses, so we need to magic hat pad it to all 3 terms, and that's going to give me 2x squared plus 6x minus 8. Okay? That's all we're doing with that too. Now the last example. Okay? This is how complicated they can get. They can actually even get more complicated than this, but this will be about the toughest we will do this year in Algebra 1. We're looking at the negative of g of 3 of x. So g of x is equal to x squared plus 4x, or sorry, not 4x. It's x squared plus 3x minus 4. All right? Now, let's see what all we're doing. We're multiplying everything by negative 1, and we're replacing x with 3x. Okay? So let's go ahead and color code this a little bit so we can have a better idea of what we're doing. We have the negative 1, and we have the 3x going in. All right? So let's find the negative of g of 3 of x. We're going to start with our negative 1 on the outside times the inside. I'm plugging in 3x wherever I see an x. So right away I see an x, so I'll have 3x squared plus, I see another 3, times another x. What am I putting in place of x? 3x minus 4, and then we can close off the parentheses. Okay, I'll give you a second to look at that. I know there was a lot going on. So we have our original x squared plus 3x plus minus 4. Then what we did was we took this negative outside and made it negative over here. Then we took the 3x that was inside and replaced it into both of the variables. Okay? And now, again, we're just comes down to simplifying. So let's start inside the parentheses. 3x squared, 3x times 3x is 9x squared plus 3 times 3x is 9x, because 3 times 3 is 9. Then I still have a minus 4. Okay? So everything's done inside the parentheses. I can't combine the 9x squared and the 9 because one's an x squared and one just has a 1. I can't combine the negative 4 and the x's because you can only combine things that have x's, like terms it's called. So all I'm going to do now is multiply everything by negative 1, use magic hat pat, the distributive property. And so negative 1 times everything just flips the signs, which gives me negative 9x squared minus 9x plus 4. Okay? So that is going to be the negative of g of 3 of x. Whew. I know that's a lot. Okay? You've got to come in, you've got to ask questions. Again, this was nothing new. I know there's a lot going on here. It's nothing new. It's still the basic, simple principles that we've done the entire time you've had me here. Okay? So we're changing y to f of x or g of x because it's going to make a big difference later through the rest of algebra and in geometry and algebra 2 and so on. Okay? So we'll see you in class. Make sure you come with questions, ready to work on your homework. I'll see you then. Bye.